Okay, good morning everyone. Okay, I'm going to revise dynamics using the past year, mid-year exam papers. Okay, first we have an overview of this topic. Okay, dynamics is about forces. Okay, and we want to understand what are the forces acting on an object or system of objects, and how these forces will affect the motion of these objects. Right, so starting with forces, you need to identify the types of forces acting on an object. Okay, and usually we use a free body diagram to draw and label these objects. If a question requests you to label, please write the name of the force in full. Okay, with a clear and correctly labeled free body diagram, okay, we can proceed on to analyze the problem. The main question we ask normally is there a net force acting on this object? Okay, if the answer is no, there's no net force, then we can apply Newton's first law of motion, right, which states that object will either stay at rest or continue with motion with a constant speed in a straight line. Okay, that means there's no net force. This is also known as the law of inertia. On the other hand, if there's a net force acting on an object, okay, we expect that we can apply Newton's second law of motion, okay, where we basically can write down an equation for calculation that the net force acting on object will be equal to the mass of the object multiplied by the acceleration of the object itself. Okay, so this helps us to apply Newton's second law of motion. And very often we may have to draw vector diagrams, okay, either using vector addition. Okay, if it's Newton's first law, for example, there is no net force, then there could be, for example, three forces acting on object. Then we'll expect to have a closed vector triangle. Okay, you start the first arrow, second arrow, and then a third arrow for the force, the third force. You should together form a closed vector triangle like this. Okay, on the other hand, if there is a net force, then the diagram might look a little different. Okay, for example, if there are only two forces acting on an object, right, then you draw the first force followed by the second force, F2, and together there's a net force. You start from the point of first force, right, and then continue with and join it to the end of the second force. So this will give you the net force caused by F1 and F2. So this vector addition. Okay, very often we also want to resolve forces, right, along two perpendicular directions. Okay, so most often is, for example, we have a force that's at an angle like this. Okay, so when we are doing vector resolution, we want to know what is the component of this force, for example, horizontally, Fx. Okay, and what's the force, the component of this force vertically, Fy. So the components of forces are always perpendicular to each other, and one of component will be F sine theta, right, which is basically Fx, Fy, right, and then this will be F cosine theta. The other component F sine theta. So vector resolution will be very helpful when we need to analyze along two perpendicular directions.